Okay, we are live. If there is anybody in the chat section, please let me know if I am properly audible and visible to you. Just give me a quick thumbs up in the chat section so that I'll know everything is fine with my stream. Okay, so I think everything is fine with my stream. Let's just wait for 1 or 2 minutes so that more students will gather and then we'll start the session. So I think everything. Okay, let's just wait for 1 or 2 minutes and then we'll start the session. If there is any question regarding the preparation of gate exam, you can ask me in the chat section. If you are having any problem or anything, then we can discuss that as well in the today's session. Okay, so till now, whatever I have covered in previous videos of machine learning, we have covered all the algorithm which are of supervised learning. What is supervised learning? Whenever we have a labeled data, then we'll use supervised learning algorithm, right? So in that we have discussed k nearest neighbor, naive Bayes theorem, decision trees, all for classification, and for regression we have discussed linear regression, and yeah, then we have discussed linear regression for that, right? So we have covered all the algorithms of supervised learning. Now we are going to discuss unsupervised learning in this session. Now the question arises that what is unsupervised learning? So whenever we do not have any labeled data, right, whenever we do not have any labeled data, then we'll consider it as a unsupervised learn we'll consider the problem under unsupervised learning algorithm. So that means unsupervised learning algorithm caters the problem whenever we have a unlabeled data. Like let's suppose we have some pictures of stars and circles. Now what would I do? Using the shape and like how they appear and all those things, I'll form a clusters, right? I'll form a cluster, one cluster and another cluster, that so that I'll know that they behave in us, they have the same properties, right? So that's what we do in unsupervised learning algorithm. Similarly, let's suppose if I want to form a recommendation system. So in recommendation system, what happens? All the news, or let's suppose if somebody wants to, like if somebody have clicked on a news topic, right, new a general news, if somebody likes, then what recommendation system does, it would suggest all the news, general news, right? If somebody likes Bollywood news, so then it would suggest Bollywood news to them. So what is happening here? That means we have formed a cluster, right? We form a cluster so that we can work on unsupervised learning, that we cater that using clustering algorithm. So in this session we are going to discuss first clustering algorithm, that is k means, right? And in further sessions we are going to discuss furthermore clustering algorithm. So if I'll see here, what is unsupervised learning? Unsupervised learning clustering algorithm are used to identify inherent patterns, grouping or structures in the data without the need for labeled output, right? So whenever I do not need a labeled output, so let's suppose I have these, so using groupings I'll form a clusters here, right? I'll form a cluster, right? So we'll form a cluster, and whenever there is no overlap, then we'll say that that is soft clustering. If there is a overlap of two clusters, then we'll say that hard sorry, if there is overlap of two clusters, then we'll say that that is soft clustering. If there is no overlap, then we'll say that that is hard clustering, right? So you can see that clustering is a task of grouping a set of objects in such a way that objects in the same group are more similar to each other than those in another group. So we'll use similar kind of properties, right, to form a cluster, right? So what would we do? Let's suppose we are forming a group here, right? So it has similar properties between this group as compared to another group, right? So we are forming a cluster so that I'll know that in this group all the elements behave in a similar manner. and in another group all the elements behave in similar manner to in this group, right? So that's how we'll do clustering. Here are some popular unsupervised learning algorithms. Popular supervised learning algorithm is k-means, hierarchical clustering, DB scan. So in this session, what will we do? We'll see some questions on k-means. First, we'll understand that how k-means work, right? And then we'll see some questions, and then we'll see that why k-means does not work for all of the problems, why we need another clustering algorithm if I have one algorithm that is k-means. So that means we'll see that what are the disadvantages of k-means, or what, where are the places where k-means does not work, right? That is my k-means clustering that we discuss in today's session, right? We have two types of clustering. I already told you: hard clustering, where clusters do not overlap, and soft clustering, where clusters may overlap, right? So you have to remember these two things, that what is hard clustering and what is soft clustering. Okay, so let me know if there is any question up to this point. Otherwise, we'll discuss what is k-means clustering. Okay, does anybody have any idea how do we work on k-means clustering? What is how we work on k-means clustering? So basically, if I talk about k-means clustering, it depends on distance, right? So what would we do? Let's suppose I have some points here. I have some points. So what would I do? I'll consider any 2 points. Let's take any 2 points. Let me consider this point and this point. Let's say I have defined here, let's say I'm going to take two clusters here. I'm forming two clusters here, right? So what is k means? Let's suppose first of all I start with that I have to take two clusters. I am just making you understand with an example. Let's suppose if I decide that I have to take two clusters. So in general, in this data set, you can take any 2 points. So I have taken these 2 points. So what would I do? I'll just, let's take all the points which are closer to A as compared to this point B. So let's suppose I find out that we have 1 point more here and we have 1 point here. So I find out that all these points are closer, right? And then in for this, I'll take that all these points are closure, right? So I form here two clusters. So two clusters, how I made? I have seen that the all the points which are closer to A as compared to B, right? So that means I have to find out distance of all the points with A and B, and I'll form one cluster. Like take one cluster and name it as cluster of A, those points which are closer to A as compared to B. And in B, in the second cluster, this is first cluster, this is second cluster, and in the second cluster I'll take all those points which are closer to B as compared to A. Now you would say work is done. Okay, we got two cluster, but no, right? Work is not done. Next thing I have to do is just take, like, you can see that how many points I have here: 1 2 3 4 5 6 7, right? So just take average of these 7 points to form another centroid. Basically this B point is working as my centroid, center of the cluster. This is working as a center of the cluster. So what would I do? I'll find out average of these 7 points. So let's suppose x1 x2 is a point, if I'm talking about 2D coordinate. So what would I do? I'll take all the summation xi's comma summation xj's, right? I'll take a summation over n if it has n points. So I'll take a average. So let's suppose your cluster move here, you would get another average here. So now what would happen here? Now this would not be the centroid. Now this point would become a centroid. Similarly in this, which point would become a centroid? This point would become a centroid, right? Now we'll form a cluster. So let's suppose if I'll try to form a cluster here, now this would become a cluster and this would become a cluster. Now likewise this will form a cluster till then that we do not have a difference between previous A and new A. There is not much of the difference between previous centroid and new centroid. Then I'll work like that, right? So let me know if this thing is clear. So what is happening here? Let me tell you in general. Let's suppose I have to form a k clusters in a data set, right? So what would I do? I'll take k points, any general k points, and I'll take all those k points. So I have to form k clusters corresponding to those k points. So what would I do? I'll find out all the points in the data set given to me, the distance of those points with these k points which I have chosen at the start. right? So what would I do? I'll take one of the point and see the taken k points, which of the k points have the minimum distance with this point. If this point has a minimum distance with the first point which I have taken, so I'll put that in the first cluster. And similarly for the second point, I'll put that in the, let's suppose it has a minimum distance with the third point, so I'll put them in the third cluster. So that's how I'll get a k clusters. But now work is not done. That you would think that okay, we got k clusters, work is done, but that is not happen. Now what you have to do, just take a average of the values of the cluster. Let's suppose in this I have 5 points, 1 2 3 4 and 5. Previously I have taken this 5 as my centroid, right? This 5 considered as a centroid. Now what would I do? And right now I'll do 1 plus 2 plus 3 plus 4 plus 5 and divided by 5, right? I'll get some value and that would be my new centroid. Centroid means that would be the center of the cluster, right? I have to take all the points that are closer to this centroid in this particular cluster, right? So let me know if this thing is clear. Okay, if this thing is like, if there is any confusion, let's just consider one example, then it would get more clear to you. So you can see that they are saying that use k-means algorithm to divide the following data into two clusters. So I have to use k-means algorithm to divide the following data into two clusters and also compute the representative data points for the cluster. Data points for the cluster is centroid for the cluster, right? So I'm going to use that. So let's suppose first I am considering two cluster with the point 2 comma 1, that is my A and that is my B, 4 comma 3. Or yeah, so I'm taking these 2 points as my cluster, right? So I have the points 1 comma 1, 2 comma 1. Okay, 2 comma 1 and 4 comma 3 I already have taken. So the remaining points are 1 comma 1 and 2 comma 3 and 3 comma 2 and 5 comma 5. So we are left with 4 points. We have to form a cluster. So let's say I'll find out distance with 2 comma 1, distance with 2 comma 1 and distance with 4 comma 3, distance with 4 comma 3, right? So just find out distance of 2 comma 1 and 1 comma 1. What is the distance? Square root of, so I already told you that if I have 2 points, x1 x2 and y1 y2, if I have 2 points, then to find out the Euclidean distance. If distance is not there, different types of distance, but if any distance name is not given, we are going to use Euclidean distance, and that is y1 minus x1 square plus y2 minus x2 square. That is your distance formula, right? So let's see, 2 minus 1 square and 1 minus 1 square, that means square root of 1, so we'll get a distance of 1 unit. And if I'll find out here square root of 4 minus 1 square, that means 3 square, and square root of 3 minus 1 square, that is 2 square. That would become 3 3 is 9, 2 2s are 4, square root of 30, 2 comma 3. So let's find out. So it would give me 2 as a distance, because 2 minus 2 0, 3 minus 1 2, 2 square 4, and square root of 4 is 2. Similarly here 4 minus 2 gives me 2, square root of 2, so we'll get a distance 2. So because, okay, so we get this distance as 2. Now let's talk about 3 comma 2. 3 minus 2, that is 1, 2 minus 1, that is 1, so square root of 2. And here 4 minus 3, that is 1, and this is also square root of 2. Okay, 5 comma 5, 5 minus 2, that is 3 square, and 5 minus 1, it would become 3 square and 4 square, 16 plus 9, so it would give me distance 5, and it would give me 5 minus 4, square root of 1 square, 5 minus 3, that is 2 square, so that would give me square root of 5. So right, so now I have to form a cluster. So I have the center here, let's say this point is 2 comma 1 and this point is 4 comma 3. So you can see that this 1 comma 1 point is close to 2 comma 1 or 4 comma 3. 1 comma 1 is close to 2 comma 1. So I'll put this in this cluster 1 comma 1, right? This point is A, this point is 4 comma 3 is B. Now 2 comma 3 is with 2 units of 2 comma 1, 2 units of 4 comma 3. So let's consider it in any cluster. Let me consider in this 2 comma 3, right? I'm considering it here. Now 3 comma 2. 3 comma 2 is square root 2 distance with this, and square root 2 distance with this. Again it is same. So I'm considering, you can, if the distance is same, then you can consider it in any cluster, it doesn't matter. So let's suppose I'm considering it in this 3 comma 2 in this second cluster, and in this 5 comma 5 is closer to 4 comma 3, so I'm considering it here. So I got two clusters here, but work is not done. I have to find out a new centroid. Previous centroid I have taken by myself, that is 2 comma 1 and 4 comma 3, right? This is the centroid I have taken. Now new centroid. So if I'll write down new centroid, a new would become average of these values. So let's take x1 plus x2 plus x3, that is 1 plus 2 plus 2 divided by 3, and then 1 plus 1 plus 3, that is divided by 3. So if you would solve 5 by 3 comma 5 by 3, this is new centroid, and b new is 3 plus 4 plus 5 divided by 3, and 2 plus 3 plus 5 divided by 3. So what would you get? 5, 6, 7, 8, 9, 10, 11, 12. That would give me 4, 5, 6, 7, 8, 9, 10. 10 by 3. Right? So this is new cluster. Now you have to do everything what we have done for these 2 points, for this point, these 2 points. Now you have to form a new cluster. Let's take this center as 5 comma 3 comma 5 comma 3. So this is new centroid, and this is new centroid for the another cluster. Now let's find out. Now let's take 1, 2, 3, 4, 5, 6. You have given 6 points. Just find out the distance with 6 points with this point and this point, right? And then you would see whichever distance is minimum, right? If 1 comma 1 for 1 comma 1, if distance for this 5 comma 3 comma 5 point comma 3, 5 by 3 is minimum, then I'll put this 1 comma 1 in this cluster, and then I'll put in, otherwise I'll put in this cluster, right? I'll do the same process again and again, right? So that's how we'll get our cluster. So let me know if there is any confusion in the calculation. I'm not doing it because it would get into numerical, because get into decimal, because 5 by 3 is something 1.3, right? So we have to solve 1.6, so I have to just find out the distance in decimal, right? I do not want to do that. So first, what would I do now? uh, I'll put it all these points in the clusters, and then I'll again take a average, average, then I'll renew my centroids again. And once I get my renewed centroid, I have to repeat this process on loop, and I have to repeat the process until there is no difference, or I can say that very less difference between the previous centroids and new centroids, right? And that would happen if points are not moving from one cluster to another cluster, right? So that's why that would give you a perfect clusters. But you have to understand that you are using here distance algorithm. I previously as well told you, when we have worked on distance algorithm, right? You have to be very like, you have to be very conscious, like whenever you are using distance, when you have a large number of data set, then you cannot rely on distance algorithm, right? So we'll discuss the disadvantages of k-means, right? And where k-means does not work. But let's see some questions which, like, first, okay, so there is one more important thing before discussing question, that here I have like taken by myself, or it is given in the question that it, you have to divide it into two clusters. But how would I decide that? How would I decide that how many clusters I have to take? How would I decide? Anybody have any idea that how would I decide that how many clusters I have to take? Let me know if anybody have any idea that how to take number of clusters, that how would I decide that okay, that particular number of clusters you can take. So there is no perfect method, but we have a elbow method which works on oh, like we have to take, which works on sum of squared error. So what you have to do, you would take number of clusters, right? So let's suppose if you are taking one cluster, so you would have like maximum error, right? And if you would take two cluster, three cluster, four clusters, if you would increase number of clusters, so what would happen? If you would increase number of clustered, your error would decrease. And how would you find out the error? Because you have given your data, right? You have given uh, you have given the initial data. So you can use that to form us to determine the optimal number of clusters. Okay, so and where this elbow, like there is no much of the difference between any two clusters, then that would take as the number of clusters. Right, now let's discuss some questions. So this is a question, guys. Tell me, given the data set, we have given some points 1 1 3 3 4 4 5 5 6 6 9 9 0 3 3 0, and assuming the initial centroids for 3 means clustering. So that means we have to take 3 clusters here to be C133, C255, and C366. One iteration for K means clustering will update C32. So what would we update C32? If I'll apply clustering algorithm once, so what would be the updated C3? That means what would be the updated centroid for C3 cluster? Just tell me, guys, what would be the updated cluster? So initial centroid they have taken in within the data set, right? 3 3 5 5 and 6 6. So you have to tell me that if I'll apply one iteration for K means, what would be the updated C3? So you have to check that which of the points are closer to 6 comma 6 as compared to another point C1 3 3 and 5 5. So let me know, guys. Just try this once and let me know what would be the answer. Tell me, guys. So if I'll see this, let's suppose if I'm taking a cluster C3 here, right? So if I'll take a centroid 6 6, can you tell me that if I'll take points which are 5 5, 5 5 is closer to C2, 4 4 is closer to again C2, or 3 3, you can take anyone. 3 3 is closer to C1, 1 1 is closer to C1, 0 3 3 0. All these are closer to C1. But we have 1.99 which is closer to 6 6. So it has only 2 points in this cluster. Now what would I do? For updating the iteration, for updating the centroid, I'll take an average. That means 6 plus 9 divided by 2 and 6 plus 9 divided by 2. So that would give me 15 by 2. So that means 7.5 comma 7.5. So it would become 7.5, right? 9.9. Right, Turkendra, 9.9 would be the point in this cluster. But for the new centroid, you have to take the average, right? So what I have done, 9 plus 6 divided by 2, 9 plus 6 divided by 2. That would be my new centroid, 7.5. Right? 7.5 would be the new centroid. Let me know if this thing is clear or if there is any confusion at all in this. Anyone, guys, if there is any little bit confusion, you can just tell me. If not, let's move forward. Okay. So this is another question. This is GATE DA 2024 question. Euclidean distance based k-means clustering algorithm was run on a data set of 100 points with k is equals to 3. If the points 1 and 1 and minus 1 and 1 are both part of cluster 3, which one of the following point is necessary also a part of cluster 3? Just tell me, guys. If 1 1 and minus 1 1 are points of cluster, are both part of cluster 3, then which of the point is necessarily also a part of cluster 3? So you can answer this question by plotting the points, right? If I plot the points 1 1 and minus 1 comma 1, so 1 comma 1, okay, let's see. If I'll talk about 1 comma 1 is here, 1 comma 1. And if I'll talk about minus 1, x is minus 1 and y is 1. So we have this point here, minus 1 comma 1, right? So let's see where is 0 comma 0. 0 comma 0 is here. This is 0 comma 0 and 0 comma 2, right? This is here. This is 0 comma 2 and 2 comma 0. 2 comma 0 is somewhat here. 2 comma 0 is somewhat here. And 0 comma 1. X is 0, y is 1. So 0 comma 1 is here. Just tell me, guys. Right, which of the option is true? So you can see that if I'm forming a cluster by taking these 2 points, so if I'll consider, like, let's say this circle, this 0 comma 1 would always inside that cluster, right? If I'm considering these 2 points, so the points between these two, I cannot form a cluster like this and this by leaving this point. I have to consider this point, na? So that's why if I'll form a cluster, it would be something like that. So that's why 0 comma 1 is always there. So option D is correct. Right, Kendra, option D is correct here, right? So that's why we can say that here this 0 comma 1 is also a part of cluster 3, right? Now I hope this thing is clear, but let's see what are the limitations of this k-means algorithm. This does not work in every case, so that's why we need different type of algorithm, that is db scan, hierarchical clustering, all these algorithm, because k-means does not work. So let's suppose we have spherical clusters. Let's suppose our data set is something like that. If I'll take a distance, if I'll take a distance between this point and this point, this is much closer as compared to this one, right? So it has to take this as a orange one, but there is a separation here. These points are very close to each other, so that's why I cannot use distance here, right? Because distance does not work in this type of a clustering, in this type of a data set, right? So I can say that whenever we have these kinds of data set, like see this kind of a data set, again this point is closer to this point as compared to this point, right? These 2 points are very closer, but here you can see that there is a separation between 2 clusters. So whenever we have spherical clusters or equally sized clusters or have similar variances, then we k-means perform okay, k-means perform well when clusters are spherical, equally sized and similar variances, but in these cases it does not work well, right? So it does not work well in these kinds of cases. Now, next thing is it is sensitive to outliers. Obviously, distance function is always sensitive to outliers. What is happening here? Let's suppose I have previously I have taken some points 1, 2, 2, 1, 3, 2. We have these points. Let's suppose I am considering this as a cluster with the point 3, comma 2. And let's suppose we have one point which is outlier. Let's suppose we have 25, comma 25. Obviously we are taking points 1, 2, 3, 2, and then we have sudden increase in the cluster, that is 25, comma 25. Now you can see that because of this point your centroid goes a large, like gets increased by a large value, right? So that would not work for me if there are outliers, right? Your centroid would become somewhat in at like 25 plus 3 divided by 2, that means 14. 14 would be the centroid, but my points lies around 1 comma 2 and 3 comma 2, right? So that would be wrong. So that's why k means sensitive to outlier. And just remember, whenever we have a distance algorithm, it is always sensitive to outliers. Requires specifying k. Okay, that is very difficult, that the at the start of the algorithm I have to specify k, because I do not know anything about the data set. Then how can I specify k at the start? So that's why these are some difficulties which we face in working on k means algorithm, right? So that's why we are going to discuss further more algorithm in further lectures, right? So yeah, that's all we have in k means. We are going to discuss further in further lectures, that is db scan and hierarchical clustering. So we'll have a lecture on Tuesday and Thursday. So we'll have a lecture on Tuesday and Thursday. So next lecture we'll have on Tuesday. And guys, tomorrow we have one lecture that is basically on how to prepare for gate, what are the like do's and don'ts. So just a quick session which I'll have with you, so that you can have any question you can ask there. And GFG is like having any like a small surprise for you. So yeah, you can join that as well. Okay, so yeah, that's all from my side. We are going to continue on Tuesday lecture. Right, we are going to have our lectures on Tuesday and Thursday. Like previously I do not get time, so that's why I was not able to continue the lectures. But right now I'll try to complete unsupervised learning algorithm, and then I'll try that I can uh, give you as many questions as possible, so that you can practice for machine learning. Okay, so yeah, that's all from my side, guys. Thank you for joining.